Hello NDG, this is a video for you on the control follow thing. Um, so pretty cool post you made here. It's an interesting topic. I never thought about this in a way like this before. So I started figuring out some ways on how to do this, and I come up with a pretty interesting solution. I didn't do too much of testing, but for what I've seen now, it worked pretty cool. So let's get into it. So what I've got here, simple face rig with some joints and a face mesh, and nothing but the skin cluster. So this is a clearly clean mesh scene, so that you get this from scratch. So first I'm gonna duplicate this mesh out, moving it away to have a little bit of, or maybe, let's keep it here. I always like if I do separate rigs that are feeding back into the output rig, I always like to place them on the center of the axis, or rather than having them like on the sides of it, having them in front, because I can just mirror the weights. If I'm working with skin clusters on blend chip targets. So, but I'm not in this one. So this is just quickly with some clusters. So what we want to do is have controls here controlling some lip segments, and the controls moving a little bit of other controls to get like a nice connected feeling to the controls. So let's create some controls. One here. One. Yeah. One there. Let's smooth them down a little bit. And let's do one on this side. Yeah. One for the other side. Okay. Now controls. Freeze transformations. So this one is control up. This one is control down. Left, right, or right. So here are controls. So now we show you a little control hierarchy that I need for this setup. Create group. This is our offset group. We create a group on top of that group, which will be our alignment group. So this is like the group that will be parented to stuff to follow the rig. I mean, they would follow anyway, but just to keep the space onto the rig. So this one, let's call align. Quickly renaming these. Okay. So this one is the offset group. We're working with this one already. Now let's create some clusters on this guy. Let's pick this one. Convert to cluster. It's okay. Convert to cluster. Next one. Yeah, that's cool. So see, this one will be also affecting a little bit of this middle thing, so that we can actually see our rig work. taking a while. There we go. One more from the left side. I think I had. Yeah, this one's cool. Okay. Yeah. Okay, here we go. Cluster up, cluster down, cluster right, cluster left. This naming convention doesn't make any sense for a larger pipeline, but it's just for the show. Okay, so these guys are controlling stuff. They're doing what they need to do. Now we can let's create direct connections from these controls to the face clusters. So from here to here, and actually put this. I will need to do a couple of these connections, so I'll quickly write a script. So selection this first one, then sources are so I'll explain a little bit of the Python thing here. So this one imports our Maya commands Python module, and then we have this selection will be equal to whatever we have selected. So ls is the list command. You can list anything with this list thing. Can look up the documentation for this. And then source also means our source object will be the first selection. Then our target object would be our second selection. That's it. Now we just had MC connect auto source to. That's it. Okay, so now select this thing, select that thing. There we go. Select this thing, that thing, this thing, that thing, this thing, that thing. Okay. So now, it's controlling. Let's create a blend shape from this head to the other. 24 mouse blend shape, face, make it a front of chain. Great. And turn on its target so that we have our blend shape now controlling this one. So now you can see here, when I move this guy, you can see a little bit of mesh is moving here, and I want this little movement to affect this control. So it is up. Now here comes my little setup. So what we need to do is overcome a little space difference that may occur. So what we will do is create two locators, one in world space, one in local space, which in this example is the space because I didn't align them. So create a locator, move it here. This is actually, let me write more script for this. We can choose this one. So selection, and we want to create a log equals MC dot space locator, and the name will be selection 0. Maybe runs in a for loop for each selection. then it's each dot replace. This is the string replace command, so we can change strings from here. So we will be replacing the control curve through locator world space. That's it. So now we can select all of our controls. This Unicode is an object group. Let's replace. Okay, it has. Oh, my spelling is incredible. Okay, so here we go. So now we got locators properly named quickly. I could have even added that they are already matched, but no, yeah, that's it like this. So world space up goes in here, world space down goes in there, world space right goes in somewhere there. It doesn't need to be perfectly lined up on the same vertex. Alright, so now this is our world space locators. Now we need to create the same ones with local space. So it changes to CS for control space or custom space. So we get these new controls, locators I mean. Let's align these as well. Already. And the second one is we will freeze. This first one's the world space, we won't freeze because now we are going to, let me shrink these guys down in size. We can hide these guys without. We will be attaching these world space controls to the mesh, and I will be doing this with the very cool point on poly constraint. Where is it? Here we go. Point on poly this. Point on poly that. This one. Point on poly that. Wait, maybe I don't like the position that I picked here. It may flip. Let me pick another position. So this is this R and this R. Maybe this one. That looks better. So vertex, this vertex, point on poly, and then this last one, point on poly. Alright, so what are we getting from here? If we move the jar, you can see these locators following the skin mesh, and they are also following the skin mesh. You can see here if we move this custom controls. Okay, so then we put the custom space controls locators, I mean, underneath the corresponding control align groups. So world space up goes and align up, down, down, right, right, left, left. Oops, no. Actually, sorry, not the world space, fuck, but the local space. So, alright, that's better. Now we will parent constrain from the world space locators to the local space locators. Constrain parent, parent. Ah, fuck mouse. Fucking shit, I moved. Fucking locator. Oh no. I just didn't freeze the transforms. Oh, okay, here we go. Right. Constraint part. Okay, so does every one of these fuckers have a constraint now? Yeah, they do. Okay, so now here comes the cool trick. We will use these control space locators to actually drive the control offset group, which is this one, so the control always stays on the mesh. What we will then do is subtract the actual controls transforms from the calculation so that we don't get double transformation. And I show this in the node editor, how we will set this up. So we need the control space locator, the group, the control curve, and its offset group. Okay, so we will create 2 plus minus average nodes, one for translate, one for rotate, and we will, let's make this one PMA underscore cc up plus dot translate, and this one rotate. Okay, set the operation to subtract, and now we pipe this locator transform into the input 3D1. It's important that you do it in the right order. Plug the controls translate into input 3D. Ah, fuck. I mean 3D0. I said wrong, but I put the right way. So don't hear to what I'm saying. Then the rotation into this guy, and the rotation from here into this guy. Right. Then output 3D into this translate. Output 3D into translate. Oh, fuck's sake! Where's my brain? Rotate it is. Okay. So what's this up? If I move this, it still make no difference. We don't get any double transformations. But if I move, for example, this, you can see that this control is following. Maybe what you don't want to do actually is to do the rotate thing, because you can see, so now it is just translating up. So now this thing still works in world space, because if we had this rotation in and we were to just like exaggerate here, you can see the space is mismatching between the control and the actual cluster. So you can see if you move this guy in Y, this guy moves in Y too, but his Y is word up, his Y is not word up. You can overcome this just by switching into this guy, but this will also don't give us an intuitive thing. So maybe don't go with rotation. Yeah, I'm doing this. This is also a little bit experimental for me, because this is the first time I'm thinking about doing this kind of stuff. So leave this as a world. Let's do this for the other locators. I wrote a little script for that perfectly before the video, but I will leave out rotations. Okay, so what we will do is we will create a selection. The first selection is our object space locator, so this one. The second selection is our control curve. The third selection needs to be the offset. And then we run the script, and it will create the node networks for us. Let's do this on this one. So this script, this, then this script. Alright. So now, if I move this, you can see these follow a little, and if you had one here, they would follow even more. You can see this very good on these guys. And if I rotate the jaw, they still follow and do their stuff. Okay, so let's remove all of this. And now we go with the align group. Let's parent the up align group and the, actually this one parent to the main head joint, the down align group parent to the jaw joint. Let's see what this gives us. So if we move this guy down, we are still in the right space for these things here. Okay, so for these in-between ones, this may get a little bit trickier, but you can always just parent them to the head, or whatever of these two is more prominent. Maybe I could also parent them to create like maybe unparent these guys, create like a dummy group or dummy locator, parent him under the head under the head joint, freeze the transforms, locator, head jaw, dummy, space dummy. Alright, and we can parent constraint from jaw to the to the jaw pivot. So we can constrain from the jaw joint to this constraint parent. What we can then do is pick this head jaw space dummy, hit the Shift W and Shift E key to create some keys, put this value to 0.5, so that when we rotate the jaw, this dummy rotates with 50% of that. Now we can create a group like here, side, city else. The naming convention again doesn't make any sense here, but it's just for the show. And then we can parent constraint from this jaw space dummy onto this parent. And then maybe leave them also inside the head joint. This is again just for the show. Normally, maybe not normally, let's do this now. So just remove these guys from this. So you don't want to have anything under the joints, of course. So since they are secondary controls, let me create side control. They are already been created by this one. Then I have down. Let me create this. Actually, I can just use the actual align curve. So down, constraint, parent, up, parent. Let me create JP phase controls and parent this wherever we want. Doesn't matter. So now we can rotate our rig, do stuff with it. and these guys still will act in proper space. And you can see they are still following the mesh. So yeah, that's pretty much the setup. Nothing fancy. That's it. I hope you liked it. If you have any comments, concerns, again, I made the research today on this, so there may be situations where setups like this are not working correctly because of our weird space interaction. But you can test this and tell me if something is not working for you, and then we can see what we can do about that. So yeah, until then, I will provide you with this code snippets from the script editor. So if you want to have these for speed up a little bit of this process, I mean it's not much. But anyway, you can have them. So that's it. Hope you liked it, and see you next time. Bye.